Hello, nice to meet you in our functional safety training today. My name is Markus Rau and I'm the responsible training manager within SGS TÜV. Today I want to tell you a little bit about functional safety and its implementation in the automotive industry with ISO 26262. So first of all, some definitions to understand what is the meaning of functional safety. So in ISO 26262 you will find following definition. Functional safety is defined here with absence of unreasonable risk due to hazards caused by malfunctioning behavior of EE systems. So I think this is a rather complex sentence, and first before I explain more here, I will give some more definitions about the content here. What is meant by unreasonable? Yes, unreasonable can be seen as unacceptable, or with other words, it should be acceptable. So absence of unreasonable means, okay, there's no unacceptable risk available. So the definition of risk is also very important to understand. This point is always a combination of two things. It is a combination of the probability and the extent of damage. So if the probability is high, so there's no need for a high extent of damage, so then we also talk about a high risk. Or even if the extent of damage is very high, so the probability may be low, yes, even then we can talk about a high risk. At the end of the day, of course, then we will talk more about the probability. So we'll see that we have to reduce the probability for a damage, and with this we may reduce the risk in total. And finally, the definition of hazard. The hazard can be seen as a state which may be dangerous for health and life. It's also important to understand that functional safety in general, safety talks about about health and life. Yeah? So this is an important point to understand here. So now let's come back to our definition of functional safety. So a malfunctioning behavior of EE systems, that means hardware and software, may be the reason which lead to so-called hazards. Yeah, so whenever we bring electronics in a vehicle, so this has a potential that it may lead to hazards. Yes, states which may be dangerous for health and life. And whenever the risk due to these hazards is unreasonable, so we have to reduce the risk to an accepted level to achieve functional safety. Or with other words, so if we are able to reduce the risk coming from the malfunctioning behavior, the risk of the hazards coming from this malfunctioning behavior of the electronics itself, so whenever we are able to reduce it to an accepted level, we will achieve functional safety, and it is then accepted, of course. So here are some examples for hazards caused by EE malfunctions. So examples for hazards caused by malfunction of operating functions like an unintended acceleration, unintended deceleration, unintended loss of acceleration, unintended loss of deceleration, unintended vehicle motion, and so on and so on. That means electronics in operating functions of the vehicles are directly lead to an unwanted behavior, to this so-called hazards. But also there are some examples available for hazards caused by malfunction of safety functions. Yes, so for example, we have an isolation detection or airbag function or whatever else. Yeah, so the loss of these functions or the malfunction may lead to high overvoltage, overheating, and so on. That means even functions which we bring in the vehicles for safety reasons have a potential of a risk which is maybe not accepted. Yes. So in general, we can say we have to check which hazards may result from EE malfunction. And this is typically done in a so-called hazard analysis and a risk assessment. So how to do it typically? The first step is to identify potential EE malfunctions. This can be sometimes very difficult. First, we have then to describe in detail what is the function which we implement in a vehicle, and then to understand what is malfunction. Typically, the malfunction is given with that the function is done at the wrong time. Yes, for example, we have a park brake, and the park brake will work during driving. Yeah, this can be dangerous. Yes, the malfunction is or the function is performed at the wrong time, or the function is done is not done or is not performed whenever it is wanted. For example, if we have an accident and the airbag shall open and it will not open, this is also a malfunction. This is the first step to understand what are EE malfunctions. Then the second step is to identify potential hazards with respect to health and life. So this is the so-called hazard analysis. So that means we have the malfunction and what are the typical potential hazards, what we had seen just before, unwanted behavior of the vehicle at the end. And finally, whenever we know the hazards, we can talk about the risks. So the third step is then to assess the combination of the probability and extent of damage in the case of a hazard occurs. So this means we have to assess the risk, and this is then called the risk assessment. Both things together then are called hazard analysis and risk assessment, and very often we see the abbreviation HARA. Yes, HARAC. This is what we have first to do before we know whether we have to go on with ISO 26262 or whether ISO 26262 have not to be used. Here, the risk assessment principle is shown. So in a graphic. So it's only a qualitative graphic, of course. We have the severity of harm and we have the probability of occurrence of harm. And if we are far away from from an imagined line risk acceptance limit here called. So if we are above this limit, so we are in this acceptable risk area. If we are below, so this is acceptable. And what we see here is already the level of risk which we can show, QM. This means acceptable risk, ASIL A, B, C, and D. And this is what ISO 26262 is. So it introduces a so-called level of risk for automotive functions and systems. So it's a little bit curious that it's not called level of risk. It is called automotive safety integrity level. So what does it mean, integrity level? We will see now, but first let me explain how it is defined. It is a 5-step scale. It starts with QM, what we had seen in the slide before. And then if the risk is higher, so we talk about ASIL A, B, C, and the highest one is D. So QM in this context means standard quality assurance is sufficient. So typically it is oriented to application of IATF 16949 or ISO 9001. So these are quality standards which are typically used in the automotive industry. So with other words, QM means, okay, we have sufficient things already in place to reduce the risk to the accepted level. ASIL A, B, C, or D then, ASIL X here shown, means additional risk reduction measures are required. So with other words, we have to do additional things to our QM measures. And the ASIL then describes the required integrity which has to be achieved by the determined so-called safety goals as highest safety requirements in the vehicle. So, and this is the reason why it's called safety integrity. Yes, to reduce the risk. So the understanding is that we have to achieve a level of integrity in achieving this so-called safety goals in the vehicle. And the ASIL is then always combined with safety requirements and is inherited to the derived safety requirements, top down. So let's make an example. So if we talk about the driver airbag, for example, so the driver airbag typically may have two malfunctions. It's an unwanted deployment during normal driving, and it's a non-deployment in the case of an accident. So the unwanted deployment during normal driving is typically rated with ASIL D. So this means this has a really high risk, because if the driver airbag will deploy unexpected, you may lose control over the vehicle. So it's then ASIL D though has the highest risk, but ASIL D means that we need the highest level of integrity to achieve the safety goal, which is then defined with the driver airbag shall not deploy in an unwanted way. Yeah, so this means this safety goal has to be achieved with this highest integrity level of D. So this is the meaning of the ASIL. And should be clear that the ASIL is always combined with a requirement. This is nothing else than the integrity requirement of a requirement which we have defined at the top level in the vehicle, then called safety goals. So now the question is how to achieve now functional safety. So we have seen we have to reduce the risk, but first we have to identify the risks, and then we are able to reduce it. But how? So here on top it's shown analyzing of potential hazards and assessment of risks. This is what we have already seen. This is the HARA code. So if there's an ASIL equal or higher than A, so we have to add measures to reduce the risk to the accepted level. This adding means additionally to our already established quality management or quality measures which we have. If the result is only QM, so this is the exit point of ISO 26262, and we can follow standard processes which typically follow our quality standards. But now, what means additional measures to reduce the risk to an accepted level? On the one hand, this means avoidance of systematic faults. So systematic faults are typically the faults which we bring in a product by our doing, yes, wrong specification, bad testing, yes, something missing, faults not identified, and so on. Yes, these are so-called typical systematic faults. And how shall we avoid it according ISO 26262? The standard says implement safety management, development processes, and supporting processes described in ISO 26262, which have on specific points a difference between ASIL A, B, C, and D. And it's clear for ASIL D we need typically the most effort to implement these processes. This is what we call the process focus. So many people also say ISO 26262 is more or less process standard. But on the other hand, here on the right side, we see we have also add measures in the way that we have to control random and systematic faults during operation. This means if there is a fault in the electronics itself, which may lead to a safety goal violation, which may lead to a hazardous event at the end, so we have to control it. And control means to detect faults and to have a reaction to come to a safe state. And this shall be done with so-called random and systematic faults. So random faults we will have in the hardware typically, so per definition. Hardware may fail also randomly due to environmental conditions and so on. Yes. So, but both of them, random and systematic faults, should be controlled. Of course, the first point should be to avoid systematic faults, but if we do not know systematic faults, we only have the chance to detect it and to control it. How is this be done? Yes, the standard tells us that we have derived requirements on functional level, on system element level, hardware and software level. And this is what I explained just before. We start at the top level safety goals in the vehicle, and then we derive more and more detailed requirements top down and inherit typically the ASIL, and each requirement then has to be achieved with a defined safety integrity. And this is what we call the technical focus, because at the end of the day, we implement fault detection mechanisms and fault reaction mechanisms on a technical level. And this depends, of course, again on the ASIL. And yes, it should be clear, for ASIL D, we have to do much more than for ASIL A, of course, because we need a higher integrity at the end. So now we are almost at the end of this small webinar. So what I can recommend to you is, if you want to know more about ISO 26262, visit our 5 days training program, or maybe only some modules. Also the single modules can be booked alone. So the content of these 5 days is going through the whole standard with a virtual example. Yes. So of course, it's some points it's just a little bit simplified, but I think at the end of this week we have a good understanding what has to be done in detail, and maybe you will have also then ideas how it can be implemented in your own company. An optional qualification for the so-called AFSP can be done at the end. So AFSP is the meaning of Automotive Functional Safety Professional. That means there's a 2 hours exam, an online exam, which you can do as a multiple choice test typically, and then you get immediately the result, and you get a certificate that you are AFSP. So this AFSP shows that you have visited this 5 days training and you have shown by a successful passing of the exam that you understand the interpretation of the standard. So for more information about our training program, please look in our homepage www.sgs-tuv-zar.com/fs-training. Yes. If you go into this homepage, you will find many training components also for other industry areas than for automotive industry. So for the automotive industry, we have also some additional prepared modules. The first one is specifically for software developers. That's a module K9. It's a 2 days module. Then already mentioned the K11, which shows the differences between edition 2 and edition 1. This can be done in a whole day or in a half day. Then we have some advanced modules here for the production process. K21, K22 talks about requirements engineering in the context of functional safety. K61 is an extension to the software module K6, which explains the verification of safety-related software components. And then the 2 last modules, K71 and 72, talk about more details about analytics like FTA and FMEDA. So of course, what we can do for you is also prepare specific training courses, also with respect to your already started projects when we come into your company. But what you find on our homepage are public trainings. So at the moment, all these trainings we can provide as online version. So we are prepared for doing this on a professional way with camera, with virtual flip chart, yes, with many things. And I would be happy, yes, if we book it. But maybe it can take a while when we can do trainings on site in your company, or that you will come to us and we meet together. Here, finally, the last slide, which you see our contact. Please call us in Munich. So I'm sitting in Munich, or send an email to the email address fs@sgs.com. Or if you are more interested to come in contact with our experts in our branch office in Dortmund, yes, here also the contact dates. Also here we have many experienced experts. For contacts in our worldwide affiliates, please ask us. Yeah, so we have affiliates in Japan, China, Korea, and other in other countries, and even in the US, we have cooperation partners where we can give you the contact to them. So personally, I would be very happy if I would meet some of you in trainings, yes, or in even in projects like consulting or assessment projects. So feel free to ask us, send us an email, call us. So I would be happy to find you. Okay, thank you very much. And at the end, I can say, please have success in functional safety. So we are there to help you. Yes, to go on faster in understanding the standard and faster to be in the implementation of the requirements. Thank you very much, and yes, good luck in doing this.